Alright, morning tubers. So here we are. Normally I just spin this up for you guys and let you check it out in the morning. But I figured, it was important to cover a couple things here. And yeah, I figured it was so important. I'm still in my slippies this morning. So, yeah, love the comments. They're great. They're really helpful. But if you don't know what's in that pot, then you can't really make an educated guess on how it's going to impact the environment or what I'm doing. So if you are going to make a comment in future videos like this, then you should probably go back and watch the other ones first. But for all you that don't go back and don't watch the previous videos, that is nothing but muriatic acid and distilled water. 1 gallon of muriatic acid and a 1/4 gallon of distilled water. That is it. It's not hydrogen peroxide. It's not nitric acid. We discussed how we weren't going to turn that into aqua regia already in a previous video, but that's okay. So another thing, people are talking about it releasing noxious fumes. Well, yeah, especially if you're going to turn it into aqua regia. Oh yeah, you're going to be making chlorine gas, and that's all the stuff that killed the people in the World War and stuff like that. So yeah, no, that's terrible. You need to do that stuff outside, no joke. Right now, all I am doing is I have hydrochloric acid, and it's 34.5%. That's it. Now, when you add copper to hydrochloric acid, you get copper chloride, or CuCl2. And for every copper atom that gets attached to the chloride atom, 1 atom of hydrogen is released. It's an equal and balanced equation. There is no missing elements. There is no missing things just disappearing into the universe. Literally, you are left with a copper chloride solution and hydrogen gas. Now, yes, for all you guys that are old enough, yeah, hydrogen gas took the Hindenburg down. Yeah, we'll get to that. Now, every reaction that you have where your copper attaches to that chloride molecule, it releases 1 hydrogen. Now, in order for it, let's see what I got written down here. I'm sorry. Okay, for each reaction cause 1 mole of hydrogen for every mole of copper used. Now, a mole, for all you guys that know, 1 mole of copper is 63.546 grams. So for every 63 grams of copper we put in here, we're going to get the same amount of hydrogen gas released. Now, I know that sounds like a lot. I know. But if you look at my videos, we are literally putting in maybe 1 to 2 grams of material at a time. So, and to put that in perspective, let's see. Hindenburg had upwards of 9 million moles just to get it off the ground, and even more once the air was less dense. And the higher it got, it needed more. So in order for it to cause its dangerous capability of combustion, it had to reach 9 million moles. Not only reach that, but to be sustained in a small contained area to ignite, and it needed an ignition source. But so in order to create a combustible area, hydrogen's funny. You can get it in balloons, you get it in cars, you can get it. It's funny how we use it, but yet there's such a wide span from 4 moles to 77 moles in an oxygen-rich environment to cause an explosion. So yeah, it sure can. If you got your lid closed here and it's not going out your fume hood, and it's getting trapped in here, yeah, you better believe that by the time you come back in here next morning, you flip that light on, yeah, you might cause yourself an explosion. Don't do that. Do your own research. But if you don't, then, I hope we learn a little something here today. I really do. Okay, so with that being said, let's see. I would need, in order to cause a potentially explosive, dangerous situation in the volume. Yeah, we were just talking about how people measure their shops in square inches. Well, I'll be darned. I had to measure my shop and find out the volume of my damn shop. You guys care to guess? Leave it in the comments. Oh my word. Anyways, in order to reach an explosive situation, not only would I have to have every inch of my shop sealed up, I would also have to put in, let's see, what do I got here? What did I figure out? I would have to put in 2,320 grams of copper in this and allow it to sit in there and do its reaction undisturbed without opening up a door or venting my shop, and then somehow, set it up like the Mythbusters did there and flip a switch to cause an ignition. So, yeah, I'm sorry, but the hydrogen being produced in my process right now is nowhere near dangerous levels. There is no nitrogen or no nitric acid or anything in there. The very minuscule amount of chlorine that may have somehow ended up in there throughout this process, it may have caused a slight reaction in the beginning, but that has since disappeared. There's no way it can still exist with that much material in there. It just can't. So I know you guys have your concerns about the impacts on the environment. Also, for people that don't know, e-waste, it's not only lucrative, which sucks because people will go for gold however they can and not care, but it's a lot smaller footprint on the environment. It is when you're extracting gold from a ton of electronics, literally 1 ton of electronics, versus how much of a footprint it costs to pull new gold out of the ground. So if you guys want to do your research, that'd be great. I did find out the reason why it's turning brown a little bit is because, some of the copper is plating out, but then it's going to come back, and it's all right. That's normal. I mean, when you're dealing with electronics, you get some dirty solutions. It's going to happen. So the only variable, your acids stay the same if you use the same thing. Your system stays the same if you use the same amounts. Things stay the same. The only variable really in this process right at the moment is the electronic material. So you need to take that into consideration before you just start chucking it in there. And I know you guys hear me stumbling around and everything else, and you guys see me, but I've got notebooks of my experiences and my experiments. This one's for October. And I've got dates, and what I put in there, ribbon ends and closely cut, what the reaction was, how it did, what the temperature was, so on and so forth. And I've just got days and days and days and what's happening in there. So yeah, I know you guys see me just stumbling around, and when I'm trying to teach something or maybe share some experience, it's hard for me to do stuff scripted. It really is. So we're just going to go off the rails here, and we're going to try to, just stay unscripted still, but just lay a little knowledge on you. So no, I don't suggest you go stack this crap up underneath your stairs in your wine cellar and hope to not have something happen, because that's not the way this works. But guys, if you go and you do it safely and you do your research, then this can be a really fun and safe hobby. It really can. And if you don't and you still feel like it's dangerous, bring your stuff on to me. I will do it safely. I don't toll refine, and I don't do that for people, nor do I allow anybody in my shop. Well, except for you guys. I realize that, I've been inviting you guys into my home, and I appreciate it. A majority of you don't complain what kind of pop I have or anything like that, and I appreciate that. And for all the people that don't enjoy the kind of pop I have over here at my house, I have a water tap. If you don't want that, I'm sorry, but go to somebody else's house. And for all you guys that are sticking around, thank you very much. This is the morning Stockpot update, and we will see you this evening unless I find something cooler to put on here. If my wife is watching, I love you. And to my kids, go wash your face.